Welcome, ladies and gentlemen, to your MN48 notes, where we're going to talk about the surface area of pyramids. In the instructions, it says find the area of each lateral face, and I'll tell you what a lateral face is here in a moment, and the surface area of the regular pyramids. Now, I can't stress enough this word regular, because of course if you have a regular pyramid you have some form of a regular shape, like a square with 4 equal sides, or a pentagon with 5 equal sides, a hexagon with 6 equal sides, and so on. In this case, looking at letter A here, we have a square pyramid, which means that this side is going to equal this one, in the back there, and right here. And it's hard to, since we are talking about a 3D shape, it's sometimes hard to really see that. So we do have a base of a square and then triangles on 4 of these sides meeting up at a common vertex, which is what kind of is the definition of a pyramid in general. Now, those 4 triangles meeting up at that common vertex are going to be congruent. You have 4 equal triangles, and those triangles are what we talk about as lateral faces, or a lateral face. In this case, we have 4 lateral faces that make up this square pyramid. Okay, so just kind of needed to touch base on some of that little background before we actually got into finding the surface area of this pyramid. But let's start with find the area of the base. That's going to be straightforward enough just because the base is a square. And that's going to be base times height, and in this case it's 40 times 40. So the area of the base is 1,600 feet squared. So up here it says area of base. Let's put 1,600 feet squared. Okay, now we want to find the area of one of the lateral faces, so one of the triangles. And if you look, what you have here is the base of this triangle, which is 40 feet. And you need the height of this triangle, which is actually called the slant height, because it's not the height of the pyramid, it's the height of the lateral face. The height of the pyramid is very clear right here. It's going from the peak down to the base at a 90-degree angle, and that's 21 feet, as it says right here. What we don't have, though, is the length of this slant height. So I'm going to create a right triangle within here, and I don't know if you see it, but it's coming from the vertex down, hitting at a 90-degree angle, the base, and it's coming out at a 90-degree angle, and it's coming back up with that slant height. Now, the length of this square is 40, and if you look in here, the back length is again 40. If you come back here in the middle of this square, and you cut across it, that is also 40. Well, this length from here to here is half of that length, so this length right here is 20 feet. So it's half of the length of the square. So I'm gonna erase, I'm gonna try to erase parts of this here. Okay, so now we have a triangle, and I'm gonna put this out here. We have a right triangle where we have 21 feet here, 20 feet here, and we need to know this. And of course, if we know 2 sides of a right triangle, we use Pythagorean theorem to solve it. So we have 21 squared plus 20 squared, since those are our 2 legs, and that's going to equal our hypotenuse squared. And when you solve this, and we've done this many, 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 many times, you want to make sure you can do it in your calculator, doing the right order of operations, but you should get a length of 29. So this length right here is 29, which means that our slant height is 29. So now let's find the area of that base, or excuse me, the lateral face. So we have area of lateral face is going to equal a triangle, base times height divided by 2. The base of that triangle, as I mentioned before, is 40. The height we just calculated, which is 29, and we divide that by 2. And when we multiply those together and we divide by 2, we end up with 580 feet squared. That is one, and I'm going to actually cloud this now that I'm thinking of it. That is one of our lateral faces. That's what they want up here. It says lateral face area 580 feet squared. Now to find the surface area though, we have the base area, we have one of the lateral faces, but we need to remember that there is actually 4 faces, 4 of these. And that's going to give us an area of 2,320 feet squared. Now to find the total surface area, what do? We add the area of the base plus the area of all of our lateral faces, and that's going to give us an area of 3,920. So up here, the surface area is 3,920 feet squared. So nothing different than what we've been talking about, except that the lateral face idea, you may not have known how to do that. And then, of course, to find that slant height of the lateral face is an important component of pyramids. If we come down here, we're just going to find another lateral face, or excuse me, another area of a surface area of a pyramid. In this case, we have a pentagon. So let's start with the base. So area of the pentagon. And really, you know, just like I've always done, I'm going to draw just part of that pentagon. We have 8 meters right here. And in this case, they are showing us even our height of that one triangle, which is 5.5. So this is a nice, we don't have to do a lot of computation here, but it's going to be the base of 8 times the height of 5.5 divided by 2, that's the area of the one triangle, and then in a pentagon, there's 5 equal triangles. So the area of this base, if you calculate it out, is going to give you 110 meters squared. I'm going to come over here, area of the base, 110 meters squared. The lateral face is a triangle. Now again, we have to kind of keep an eye on this. We have that this right here is 5.5. We have this right here, which is 4.8. What we don't have is the slant height, which is really important. This is what we need to find. So I'm going to take this right triangle out here. I'm going to put 4.8 right here. I'm going to put 5.5 right here. And then this hypotenuse is what we need. Oops, I'm going to kind of makes it look like it's 4.8 here. I'm going to say this is x. Okay, so again, another quick Pythagorean theorem calculation will give us our hypotenuse that we would like. And when you use Pythagorean theorem to find that, you'll find that you have a hypotenuse or a slant height of 7.3 meters. So now we can find the area of one of our lateral faces, which is going to be base times height divided by 2. My base of that triangle is 8. The height we just calculated, which is 7.3, divided by 2. And if we do that calculation, it'll give us 29.2 meters squared there. So up here is 29.2 meters squared. So again, I'm going to cloud this because this is the area of our base. We're going to take this lateral face calculation and we're going to multiply it by 5 because there's 5 faces. And that, when we multiply those together, gives you 146 meters squared. And I'm going to cloud this. So, again, to find the surface area, you're going to add your 110, which is your base, plus your 5 lateral faces, and that's going to give you 256 meters squared, which we'll put right up here. So really, if you notice the above problem and the below problem, the biggest thing with these is to find the slant height. And really, that's always using Pythagorean theorem, or sometimes SOHCAHTOA, depending on the kind of problem. And you'll have the height of the pyramid. If you're given the height of the pyramid, and you're given, in this case, it was the apothem, but of course it could also be part like the square one, where it was just half of the base. Then from there, you can use Pythagorean theorem to find this hypotenuse, which is the slant height. Well, we'll take any questions you have in class tomorrow. Thank you for tuning in.